This video is about the theorems of chords and radii. So in a circle, if a radius, this line right here, or a diameter, so if the line was extended all the way across the circle, is perpendicular to a chord, so that means it's going to have a right angle at the intersection point, then it bisects the chord and its arc. So we can use the bisected chord then to find different lengths of the circle. And vice versa, in a circle, the perpendicular bisector of a chord is the radius. So this idea helps us with trying to find missing side lengths with chords and radii. So in number one, we need to find AB. Well, AB is this whole line. So AB is the chord, which means that it's bisected into two congruent parts. We need to find the missing side. So we're going to draw in a radius from M to B to create a triangle. Now, when we create a triangle, we already know the length of MB because we know that this line with M right here is also a radii. So both of these are radii, so they're going to have the same length. So I can add 7 plus 18, and I get that the length is 25. So now that I know my radii is 25, I can use that triangle to find part of the chord. So I'm going to call this part x. I'm going to do Pythagorean theorem. So 25 squared equals 7 squared plus x squared. I don't want to use 18 because that's not part of our triangle. So when I square this, I get 625 equals 49 plus x squared. Subtract 49 from both sides, I get 576. When I take the square root, x is 24, which means this part of the chord is 24 and the other part of the chord is also 24. So AB is equal to 24 plus 24, 48, and this one has meters as its unit. So in number two, we want to find JK. So again, JK was bisected. We already have a radii over here, which has a length of 30. So when I draw my radii from M to K, I know this also has a distance of 30. So again, I can do Pythagorean theorem in my triangle. I'm going to call this part down here x. So 30 squared equals 18 squared plus x squared. So 30 squared gets us 900. 18 squared is 324 plus x squared. So I can subtract 324 from both sides. I get 576 equals x squared. So again, x is 24, which means that each part of the chord is 24 and 24. So JK is equal to 24 plus 24, which would be 48 inches. Now, in number three, this is asking us to find MB. So I'm going to draw in a radius that goes from M to B. Now, I know that the chord, part of the chord is 4, and the distance from the center to the chord is 3, which helps me in my triangle to find my radius. So the radius, we're going to call that side x. X squared equals 3 squared plus 4 squared. So we get x squared equals 9 plus 16. X squared equals 25, which means that x is 5. This time we're not going to double it or anything because we just are looking for the radius. Number 9, or number 4, find JK. So remember, JK again is the chord that's been bisected. We have a radius that is 15. So in the triangle, I can draw that this part's 15. Now, I don't have the second side of the triangle yet. I do know that this chord right here, this line right here is a radius. And if the bottom part's 9, 15 minus 9 gets us 6. So now I can do Pythagorean theorem. So we get 15 squared equals x squared plus 6 squared, which gets us 225 equals x squared plus 36. We can subtract 36 from both sides, and we get 189 equals x squared. Now, when I take the square root of 189, that would be a decimal. So I'm going to say that x is the square root of 189. And if I were to make a factor tree, this would break down into 9 and 21. 9 breaks down to 3 and 3. 7 and 3 for 21. So I have a pair of 3's. So this would be 3 root 21 for x. So each part of the chord is 3 root 21. So JK, I would add those together. 3 root 21 plus 3 root 21 would get us 6 root 21. Remember that the root stays the same, we're just combining like terms. Now in these other problems, we're going to have to draw a picture for this. So in number 5, a 40 centimeter chord is 15 centimeters from the center of the circle. What is the radius of the circle? So I'm going to draw a circle. And then inside the circle, I need to draw a radius that is going to bisect a chord. I need to draw another radius because I'm trying to find the radius of the circle. So if I'm trying to find the radius of the circle, I'm going to call that x. The distance from the center to the radius, which is this vertical side here, is going to be 15. They also said that the chord is 40, which means that it is bisected into 20 and 20. So now I have my triangle to find the radius. So I have x squared equals 15 squared plus 20 squared. I get x squared equals 225 plus 400. X squared equals 625. So when I take the square root, x is 25, which means that the radius is going to be 25 centimeters. Let's look at one more example. So in number 6, a circle has a radius of 15 meters. The chord is 9 meters away from the center. What's the length of the chord? So I'm going to start by drawing my picture here. So I have my radius that's going to bisect a chord. This time I know that the radius is 15. I know the distance from the center to the radius is 9. I know that this is perpendicular and bisects the chord. So I'm looking for x. So I have 15 squared equals 9 squared plus x squared. 225 equals 81 plus x squared. I can subtract 81 from both sides, and I get 144 equals x squared. Take the square root, and we get x is 12, which means each part of the chord is 12. So I have 12 and 12. So the chord, I have to add those two pieces together, and I would get 24 meters for the length of the chord.